Okay, the ninth grade curriculum is, the core of the curriculum is the World History 1 and 2 SOL courses. And it's really done with a kind of filter over top that's the history of technology. It's called Technology Through the Ages. So there's a lot of study of what technologies were developed, what are the kind of the ethics behind those technologies. We just got back from a trip yesterday, for example, to the Holocaust Museum, which I think highlighted a lot of how technology was used in ways that were ethically pretty rough. We've added a lot of projects where students are working with other students from other schools to develop websites that feature specific technologies from certain time frames, to develop presentations. Right now our students are doing a project on the ethics of technology in history, where they'll have to present pro and con sides through a public presentation in another month or so. In the spring, at least this year, we went to, just got back yesterday from visiting the war memorials, the World War II, Korean and Vietnam memorials, and also going to the Holocaust Museum. Those are kind of the big, get on a bus and go somewhere else field trips. We also do a lot of work trips and trips to UVA. So we go to UVA library for some research for the fall project. We also go to UVA for a lecture from one of the professors of political science there. And then we do some trips where students come together to either work on projects or present the results of their projects to each other. So it's about, for the ninth graders, it's about 7 or 8 field trips altogether.
It's a basic World History 2 class from 1500 to the present in World History, but the Governor's School aspect of it adds technological aspect. We study technology through the ages, as well as the basic Virginia SOL requirements for World History too. Using technology, studying technology, incorporating the things that, as a science and technology type governor's school, we're mandated to do, we're supposed to be doing. We still have the same problem. What's the problem?
It stopped. The
ball stopped. All right. Now you're going to develop a hypothesis. What's your hypothesis?
There's just not enough energy moving it.
Is we go over a lot of just normal biology stuff, but also there's a lot of the technology aspects brought in. We talk about a lot of cutting edge technology. I mean, there's a lot of biotech work that's being done every day, and a lot of it's brand new, a lot of it's really exciting, cancer research, new ways to fight diseases, things like that. So we get to go in more detail with that since we have more time in the class, since it's a smaller group. So it's a lot of that technology aspect brought in that you really can't bring into the other classes as easily since you're on a tighter schedule. So you have a lot more time to go over these cutting edge techniques, these new technologies, things like that.
The 10th grade curriculum is the biotechnology curriculum. That's SOL biology kind of at the heart of it, but it also involves much of the modern biotechnological science, DNA, a lot of genetic science, just stuff that extends beyond the basic biology SOL curriculum. There's a lot of hands-on, a lot of experimentation. There is an experiment that we participate in every year with Virginia Tech, which is a Arabidopsis genetic mapping experiment, where they give out genetically mutated Arabidopsis plants to schools, and students subject them to different conditions and see what happens. That's been a great ongoing experiment that we've done with those guys. For the Arabidopsis project, they're given seeds from plants that are wild-type plants, same as they find in nature. Then they're given seeds from plants that have a genetic mutation. And so the plants are then subjected to conditions that the students decide on, working with the folks from the Fralin Center at Virginia Tech. And so they subject the plants, the wild type and the genetically mutated plants, to those conditions, and they track the differences in the plant's development. And sometimes, there's a lot of evidence of differences. Sometimes there's not a lot, but all of that goes into the database that Fralin Center's maintaining, that helps to kind of map out the function of each of the genes that they have turned on or off with these plants. And there's also a lot of focus on the ethics of biotechnology. With students do projects where they look at bioethical questions about the development of genetically modified organisms. The 11th grade curriculum, that's a different course. That's one that is taught, it's a computer math class, which is really more of a computer programming class taught online. So for a lot of students, it's the first time that they've taken an online course. It's taught by a single teacher for all of the schools. All the communication and the bulk of the work takes place in an online environment. It's a lot of a problem-solving course more than anything. It's about how to get into a learning environment that's a little bit different and really make the most of it. The other piece of that is learning to apply a skill like computer programming to a real-world problem. How would you create a programming solution to, say, help for people in old folks' homes, or help for community service organizations, things like that. That most students are used to, in a high school setting, are used to face-to-face interactions with their peers or with their teachers. So this is a way to kind of give them some experience and some practice in how to use the electronic communication, like email, like chat, like some of the other tools that we have available to do their schoolwork. They have a project that essentially they create a computer programming solution to a problem or a realm of problem that is posed by the instructor. And that changes, but it's usually a service-oriented problem, like, you know, how would you help the elderly? How would you help public service organizations? How would you help Parks and Rec, for example? What are some things that you could do with this computer program that might help solve a problem? So students have to first identify a problem. They've got to kind of sift through what problems might, say, Parks and Rec have that could be solved with a computer program. What are some of the parameters of those problems? And then how do we create a program that's going to help solve some of those parameters? The 12th grade classes, the curriculum is very open on that one, because it's an individualized student project. Students have to do an internship, community service, a research component, and presentation on a topic, any topic that they can sell us on. So we have a huge range of topics. This year, as an example, we've got everything from somebody who's studying herpetology, to somebody who's studying equine acupuncture, to filmmaking, to technology, to, you know, just any topic, as long as the student can craft an experience that's going to be academically viable. It requires a lot of student independence. It requires a lot of students setting their own deadlines and coming up with their own plan for how they're going to achieve the goals of the project in a timely fashion.